And we're live. This is our CIT 260 group presentation for week 8. I'm James Kennedy.
I'm Mallory DeBartolo.
And this is what we're going to talk about. Oh, there we go. All right. And to Mallory for function creation.
All right. So this is our byland method, and this is our method design that we created. And I'll be going through steps 1 through 4 of creating a method. So first, we clearly define the problem. The problem is that the player needs to buy land, and we outlined the problem to be solved and all of the different things that we would use to solve that problem, and the conditions and the calculations that needed to be met. And we have our parameters and what would be returned. Later on, we created the test matrix, which is right here, which takes us through a valid circumstance, 3 circumstances that would be invalid in the method. And then we have 3 boundaries as well. And we outlined our solution and how we would create the method with some pseudocode right here. And here is our algorithm. And then we have a desk check here that takes us through our test matrix and tests our algorithm. And all of this is done before writing any code. And now we'll go back to James.
All right, I think it's showing my screen now. As Mallory said, we outlined the solution and the algorithm, make sure that it was sound. And here we translated byland into code, going through the various steps, allowing for and preventing against the various errors and that were outlined in the desk check and the algorithm testing. And here's where we implemented that code. And in terms of running the various checks, over here we have the test byland method, which was originally generated by NetBeans and then altered by us to make it easier to understand. For instance, we altered the expected result to be different in each case so that we could recognize in which case the code was failing, and we just kind of tinkered with it until it worked. So here I'm going to run the crop control test method. Oh, it's running the whole thing. Run file. There we go. And we can see that we have 100% compliance with our various tests. And now that we know that the tests are valid and that we have created code which is in compliance with those tests, we can push the changes to our repository. Now, to do that, you can either do it through through GitHub in the NetBeans client, or you can do what I do and use GitHub Desktop. For instance, we can see here that I put an extra space or extra line here just to kind of show that there was a change made. We outline the summary, and in this case, I'm going to call it presentation. Description. Is optional. Then we commit it to the master branch and push. And now we know that the current version of our crop control method is on GitHub and accessible to all of our team members. Now, in terms of the scope and lifespan of variables in this particular method, we will go to Mallory.
Okay. So in our crop control class, we have a few variables that are open to the entire class, and those are written up here. And they're private to this class. And we also have some variables that we've written inside individual methods, which die when the method is finished. And James, do you have anything that you want to add about?
Yeah. So in terms of variables and their lifespan, as Mallory said, there are global variables up here, which are alive for the entire duration of this class being called by another method, such as game or crop data or what have you, crop view perhaps. And then we also have local variables which die, and their lifespan being at the end of this bracket. A variable like that would be land price, which is only used to calculate the price of land in a particular instance, and then it just dies. And we know that, and because of this, we can have the variable land price in a couple of different functions, just for just to make it easier to keep track of. It wouldn't make sense to have like land price 1, land price 2, especially if it's unnecessary. It'd just be confusing. And let's see. Now in Java, variables are passed into functions both by value and by reference. Variables which are passed by value in Java are primitive values or primitive variables such as int or float, double, that sort of thing. And values which are passed by reference in Java are classes, for instance, such as crop data or player, map, location, or all that sort of thing. And the difference there is that the literal value put into this spot when this method is called is what is passed into it. Whereas in this instance is a reference to the class at a different location, as opposed to passing the whole thing in there. That's just sort of a way to keep the overhead of the program low, and also to protect it from potential bugs.
Awesome. And I can show an example of that in one of the methods that I wrote for an individual assignment. I wrote the feed people method and implemented it, and we're passing in two different parameters here. We have the variable, the wheat for people variable, and then we also have a reference to the crop data. And as we're referencing the crop data object, you can see down here in the method that we can get anything that is stored within that crop data object if we're passing in the entire reference to the object. So in the feed people method, we have our wheat and store variable, which is an integer, and we're setting that equal to whatever's currently stored in the crop data object, and we're calling the getter for that. And then we're using an if statement, a few different if statements to test some of the issues that we need to test for. If like the wheat for people is less than 0, then we have an error, which will return a -1. If wheat for the people is less than the amount that's in store, then we will return the crop data wheat in store, and it goes on from there. And then we're returning 0 if the method has been successfully run. And James, do you want to go ahead and show one of yours?
Sure. Okay. In the help menu view, we have a couple of different switching or decision-making aspects to it. In the get menu option method here, we have a do while loop inside of which there is an if statement. So if the user input is less than 1, or if the user input is greater than the maximum allowed, which is defined over here in the constructor, that being 5, then the program will output an error message saying that the option must be between 1 and the maximum, and then loop again. So while this condition right here evaluates to true, the loop will continue. Another example of a decision-making statement in Java is a switch statement. Here we have the doAction method, into which a parameter called option is passed into it. And the switch statement basically is governed by this option. So if an option is passed into it, which is 1, then the view goals method will be executed, that being down here, and so on and so forth. So this is a fantastic switching or decision-making method when you have a large number of cases which can be easily defined by a user input or choice, as opposed to like a minimum or maximum boundary.
Awesome. And I'll go ahead and show, to end our presentation, I'll show an example of some unit tests that we wrote. Here is our location class. And as you can see, we haven't written all of these different methods within the class yet, but to unit test it, we have written a test here that shows that allows us to go ahead and set specific values for the placeholders that we've written within the class so that we can test our code. And it prints the different values that we've written, and that is how we unit test each of our classes.
Awesome. I think that just about wraps it up. Thank you all for watching. Have a fantastic day.
Thanks.